All right, this is 2.1 vertex form of a quadratic function. So right here in red, I have the vertex form, f of x or y, right? You could call that y as well, equals a times x minus h squared plus k. The vertex is going to be h comma k. Okay, so that's our vertex, right? H comma k. And then A is going to tell us a couple of things. If A is positive, that means our graph is going to open upward. If A is negative, that means our parabola is going to open downwards. If the absolute value of A is greater than 1, it's going to be a vertical stretch. If the absolute value of A is between 0 and 1, it's going to be a shrink, a vertical shrink or vertical compression. You can use the word shrink or the word compression interchangeably. Okay, so if we look at 1 through 4 here, which ones are standard form, which ones are vertex form? We're not really going to worry about standard form yet. So vertex form would be 2 and 3. Those are in vertex form there. Okay. So for number 2 here, A is going to be 3. Right? H is going to be 1. And K is going to be 3. Be equal to 3. And then for this one over here, A is going to be negative 2 over 3. H is going to be 4. And then K would be 7. Okay. All right, 5 through 8 wants us to tell us information about these quadratics in vertex form. So we answered in class 3 things about this. We answered whether it was a vertex, or what the vertex was, if it opens up or down, and what is, if it's a stretch or a shrink, a stretch or a compression. Okay, so looking at the first one here, we use text. Our vertex is going to be, okay, 7 comma negative 1. So our h here is 7 and our k is negative 1. If you want to think of it as for the h as changing the sign, that's fine. Negative 7 becomes positive 7, and then the k stays the same, negative 1. Okay, for the next one, our vertex would be negative 2 comma negative 5. Right, we're keeping it, we're changing the sign on the x, right, the h, keeping the k the same. Okay, this one would be 3 comma 0 is my vertex. Okay, even though there's nothing over here, you could really write plus 0. So 3, 0 is my vertex. Okay, and then over here is going to be 2 comma 4. Okay, and so on. This one is negative 1 comma negative 3. Okay, negative 4, 0. 5, 1. And then negative 6, 10. Okay. All right, next thing, if A is positive here, so A is positive 3, so this is going to open up. A is positive 3, so it's going to open up. Okay, A here is 1. There's really a 1 there, even though it's not written, but it's a positive 1, so it's going to open up. This is a negative 4, so it's going to open down. Okay, positive 2, so it's going to open up. There's a 1 here, positive 1, so it's going to open up. Okay, positive half, so it's going to open up. And then negative 1, so that's going to open down. So what we mean by that is when we graph it, your parabola could open up or it could open down. So if it opens up, that's because A is positive. If it opens down, that's because A is negative. Okay, and then the only other thing here, let me draw a graph, is the vertical stretch or vertical shrink. So if I draw a graph here, okay, your standard x squared is going to look something like this. Okay, if it's a stretch, okay, that means A is greater than 1. It's going to get pulled upwards. So your graph is going to look more vertical, right? It's going to get pulled up. That's a vertical stretch. Okay, if it's a vertical shrink, then your A, absolute value of A is between 0 and 1. It's going to get smushed. It's going to get compressed down, and it's going to be wider. Okay, so for each of these, if we look at them, A is greater than 1. This is a stretch. Okay, greater than 1, stretch. It is 1, so it's going to be neither a stretch nor a shrink. Okay, it's just 1. It's just going to have the same shape as x squared. Okay, the absolute value of -4 is 4. That's greater than 1. That's going to be a stretch. Okay, stretch, right? Bigger than 1. It's 1, so it's going to be neither. It's half, so it's less than 1. It's between 0 and 1. The absolute value of A is between 0 and 1, so that's going to be a shrink or a compression. Interchangeable words. Okay, and then this is going to be neither because it's at 1. All right, let's look at some examples to graph. All right, so this one, vertex. So again, our vertex, we're going to change the sign here. So it's going to be -2, 4. Okay, your axis of symmetry is always x equals h. So in this case, it's going to be x equals -2. Since A is negative, we're going to open down. And since we're opening down, right, it's going to look something like this. Since it's opening down, that means we're going to have a maximum. And that maximum value is going to be the vertex, which is -2, 4. Okay. And then your y-intercept, we need to substitute in 0 for x. So I'm going to take my equation, y equals -2. And I'm going to substitute in a 0 here. So it's going to be 0 plus 2 squared plus 4. And when I solve that, that's -2, 2 squared plus 4. So I got -2 times 4 plus 4. That's going to give me -8 plus 4, which is going to give me -4. So my y-intercept is going to be 0, -4. All right, when I graph this, I'm going to plot the vertex. So I'm going to plot my vertex at -2, 4. Okay. I'm going to plot my y-intercept, which is 0, -4 right here. Okay. And then my axis of symmetry. Let me do axis of symmetry. I'll do it in like a light green. My axis of symmetry is x equals -2, which is right here. It's a vertical line through -2. Okay, I notice my point here, 0, -4 is 2 units to the right. So since it's symmetrical, I can put another point 2 units to the left. That's going to be -4, -4. Okay, and now I can draw in my parabola. So my parabola is going to look something, it's hard to draw in here, but it's going to look something like this. Okay, it's going to round at the top and come down. Okay, so it's going to look something like this. All right. If I wanted to add domain and range here, domain and range. My domain is going to be all the way to the left, all the way to the right. So that's -infinity to +infinity. Okay, my range, the lowest I can go here is -infinity. And the highest I can go is going to be 4. And since I'm including that point, I'm going to put it as a bracket rather than a parentheses. All right, let's do one more like this. Let's try number 18 as an example. All right, my vertex should be 5, -2. Right, we change the sign on the x, but we leave the y the same. So 5, -2, that's our h, right? It's x minus h. So h is 5, k is -2. Your axis of symmetry is always x equals h. So in this case, it's going to be x equals 5. A is negative 1/5. So that means it's going to open down because A is negative. If it's opening down, that means we have a maximum. And that maximum value is the vertex, which is 5, -2. To find the y-intercept, we're going to plug in 0 for x. So I'm going to do y equals -1/5, 0 minus 5 squared, minus 2. That gives me -1/5. Okay, -5, 0 minus 5 is -5. -5 squared is going to be a positive 25. Okay, -1/5 times 25 is -5. Minus 2, my y-intercept is going to be -7. 0, -7. All right, to graph this, I'm going to start by plotting my vertex, which is 5, -2. Okay, I'm going to graph my y-intercept, 0, -7. Okay, I'm going to put in my axis of symmetry. Let me put in my axis of symmetry here. So my axis of symmetry is x equals 5. Okay, so I have a point here on the y-intercept that's 5 to the left of the axis of symmetry. So I'm just going to go 5 to the right because it should be symmetrical. And that's 10, -7. And now I have all the information to graph my parabola or my quadratic function, right? The shape of a quadratic function is a parabola. So it should look something like this. All right. Let's jump over to a different type of question like this. Okay, where it says write a quadratic function in vertex form whose graph has the given vertex and passes through the given point. So we know y equals a times x minus h squared plus k. We know that's our vertex form for our quadratic. All right. We know that the vertex is h comma k. So I can substitute in h and k. So y equals a x minus 2 squared plus 3. Right, and the only thing we're missing is a here. So we have our h and our k. The only thing we're missing is a. What we're going to do to solve for a is we're going to substitute in 0 and 7. That's our x and our y, so that we can solve for a. So if I'm going to substitute in my point, for y, I'm going to put in 7. And for x, I'm going to put in 0. Right, and then 0 minus 2 is -4. I'm sorry, is -2 squared. Right, 0 minus 2 is just -2. And then -2 squared is a positive 4. So it's a times 4, which I'm going to write as 4a. I can subtract 3 on both sides. And now I get 4 equals 4a. And I can divide both sides by 4. And I get 1 equals a. So now I can write my equation, y equals 1 times x minus 2 squared plus 3. Right? But we don't need to write the 1 in front of there, so we can just leave it as y equals x minus 2 squared plus 3. Right? Let's see what else we can do. Let's look at something like this. Let's look at number 9. Okay. So write a quadratic with a minimum that has been shifted 5 units to the right and 7 units down from the parent function. So the parent function is y equals x squared. Right? We're going to have a minimum. If there's a minimum, that means that our function is going to open up. So that means that it needs to be positive. So a is 1, it's going to be a positive 1 still. Okay, it's shifted 5 to the right. That means we're going right 5 horizontally. So that's going to be x minus 5, because you got to switch the sign, right? It should be x minus h. So x minus 5 is to the right. X plus 5 would be to the left. And then it's going 7 units down, so we need to have minus 7. 5 to the right, 7 down. Okay, the next one, the parent function again is x squared. We have a maximum this time. So if we have a maximum, that means it's opening down, which means it should be negative. All right, it's shifted 4 to the left. So that should be x minus negative 4. X minus negative 4 becomes x plus 4. And then it's 3 units up, so we're going to add 3. Okay, 4 to the left, 3 up. You got to change the sign for the x, for the horizontal. All right, and that covers pretty much all the ideas of vertex form for the quadratic.